First question is, what is safety? What do we expect from these jobs, what we are doing? Is it a condition which is free from unjustifiable risks? Is it a condition which is considered as free from dangers? I think this is not true in tunneling. If we work in tunnels, there is a remaining risk. We had often the discussion with lawyers, for example, again, and the lawyer said, if you know that there is a risk, why do you then start this job? Yeah, because then it's clear who is responsible if you know that there is a risk. And then it came out from the insurance company that they said, yeah, then please train the lawyers, because they are not used to a situation that you are well known that there is a risk still existing when your miners start working. Now, what are the risks? I think we had them several times this day already. We have these geological, hydrogeological, geotechnical risks, which we deal with daily, I would say. We have very complex intersections. We have not precisely defined working processes compared to, let's say, the mechanical industry, building cars or so. They have quite strict processes, what happens when, but this is not always possible in our field. I mentioned it already one time this day. We have, in many cases, badly trained employees, not comparable to the mining industry. The mining industry normally takes their employees and then they work for years there. But in our field, I don't know how it is here in Argentina, but in the European area it is a tunnel comes to any region. Then everybody would like to work there because they earn a lot of money for the next 3, 4, 5 years. And then they leave this job again because it's not a perfect job, but it is a job for a short time. That's why we deal with badly trained employees in many cases. A high fluctuation, I mentioned it. Still, in many parts of Europe, I would say we have a lack of safety thinking. When I came from the German railways, for example, to Austria, I thought this is not possible. And then looking to Switzerland, they were, I would say, 1 decade in front of us. Yeah? Because we had no rescue chambers and such things until we started the long tunnels. So a lack of safety thinking also in the directors area, I would say. Sometimes not clear who does what, because the description is sometimes missing. Then we are dealing with financial pressure in this field and the contractual boundary conditions. For example, in the Semmering base tunnel nowadays, we have the big problem that the client shifted all these fire things, what Gerard presented, to the construction company and says, it's your duty. So you have to train your employees, your miners, to be a kind of fireman. Yeah, but the miners say, if you want me to be a fireman, then I would like to earn a little bit more. And this is contractual boundary conditions, what I mean. But we have to think that every accident causes the loss of our image. I mean the whole industry, the whole field of underground engineering is suffering from these accidents which we see in the media, which we see on the TV, because the people say they are not even able to build it on a safe way. So this is an image which we lose with every accident. I start with a topic which is a topic not only for the construction but also for the operation of a tunnel, because we are thinking that we have to think on safety during tunnel construction but also during operation. You cannot separate the one topic from the other, and I brought to the discussion one of the main topics which we are discussing always is the distance of the cross passages. And we learned a lot from Switzerland, of course, and I just brought up a few of the tunnels which we are now dealing with in this Central Europe region, Switzerland, Germany, Austria. What are the main tunnels to be built? Brenner Base Tunnel, 55, it's getting now a little bit longer, almost 60. January 15 about, Eurotunnel 50, Gotthard Base 57, Korm 33, Lötschberg about 35. This Lyon-Turin tunnel was already mentioned today, 52. Semmering Base under construction, 27 kilometers. These are the tunnels which we are dealing right now. And you see the different cross-cut, cross-passage distances going from 333 meters to, for example, 500 meters. The one tunnel here is situated in the western part of Austria. The other is on the eastern part of Austria. And what do you think the population, when this came to the newspaper, said? The eastern people in Austria said, aha, they spend more money on the western part people, so they are more worth, as it seems, and this cannot be. There was a big fight. Why do we choose this small distance when we are going to Italy? And why do we choose this wide distance when we are building a tunnel within Austria? Yeah? Same velocity which we run, and. The reason, I have to say, was a little bit coming from Lyon-Turin, because Lyon-Turin was already given free by the authorities in Italy. If you have something approved by the authorities in Italy, you can change nothing. Then we were looking for the Swiss projects, Lötschberg and also Gotthard, but they have a own history. Gerard knows this very well. I won't go into the detail of the history, how to come to 325 meters. And the Brenner base said, okay, we are in the western part of Austria, we take the solutions of Italy, Switzerland, and that's it. And then when the Korm tunnel went to the authority, there was an European guideline, a safety, which is called a TSI, technical specifications for interoperability, it's called, European-wide, and this guideline says the maximum distance of cross passages in the whole European region is 500 meters. What did the directors of the Austrian Federal Railway then decide? To save money, of course. Of course, the 500 meters. And there was no way to say 325 is better, because then you can save more lives or whatever. This was not able to be shown. Why was it not able to be shown? We have only one country in Europe which has a number for what is the cost for one dead people. It's only Switzerland who has a number. What is the cost if one man or woman dies in a tunnel? There's no number in Austria, there's no number in Germany. It is a big political fight to get this number. For us as a technician, it would be best to have this number available. This we ask from our politicians. Please give us a number, then we can calculate this and that, and this is the distance which comes out. However, this was the decision. I just wanted to say, there is a European guideline now available. Maximum cross-passage distance is 500 meters. That's it, and that's why we follow this rule. The Brenner base tunnel had the big problem that on the Austrian side, they would like to build 500 meters. Then we have the border, and then 333. So this is also not possible, because you are a passenger in a tunnel and you would like to know, okay, is the distance now this or that? You don't know even when you pass the border, because the border is 2,000 meters of overburden. So you, there could be a signal in the train and say, okay, now we are in Italy, more safer than in Austria. It's not possible. Yeah? So it was the decision, okay, we follow the decision of Italy, which was then 333 on this very specific project. Yeah, I come to the Korm tunnel. Korm tunnel is 2 times 33 kilometers long. Gerard mentioned already how far are the distances from one single point to be driven from the logistics point of view. We have quite high distances. We have from the 1 point 16 kilometer, from one shaft, 16 kilometer drive, and with the one tube and with the other 17 kilometers. And this is a quite high distance for the construction lot, I mean. So we had to think on special solutions. Of course, self-rescue first. A standby safety device has very high priority, and the focus is on a very good organization for the fire protection and fire prevention. I don't want to repeat what you all said, Shara, already. Fire prevention has to be done first. We installed a safety center when we never had before. A safety center which is working 24 hours, 7 days, which is very clearly monitoring every person who comes on the site. There's a big fence, by the way, and everybody is controlled who gets into the construction lot. A control system, of course a monitoring of the ventilation units, a communication center for each construction lot so that we also can see who is where, and a connection to the rescue centers around. A lot of internal trainings have to be done. First aid, first and advanced fire extinguishing, fire protection plans according to the construction phases, training of the underground guides. I mean, the fire brigade is coming, but there must be somebody who says, okay, today we are working here and there because it's a little bit complicated underground structure. So the fire brigade has to be, let's say, told, okay, please go this way to come to the right place. Then we were thinking on how fast can a fire brigade be? I mean, a well-trained fire brigade. In the worst case, the training gave us, we go 10 meters per minute. This is not very much. This is if I go from here over there in 1 minute. But we did a training with a smoky area, and there's no way because you can't see anything, and the fire brigades are not trained to this situation underground. So they are going in groups, they are hanged together, always 3 persons, they are hanging like on a chain, and they move together forward, and they, in the worst case, can just move 10 meters a minute. If we would have 250 meters, and this is what we showed the authorities, we will need 25 minutes to come to the place where the fire occurs. In the best case, then we did some studies, in the best case, if we can go 30 meters a minute, we need 8 minutes to come there. There were several tests done at the Column Tunnel. Then another point talking about the cross passages is how do we install the doors? The designer in the first stage did it in this way. One tube is here, one tube is there. We install doors. If you escape from here because of fire or something happened on this side, you escape on this way. But the doors on this side also were from the designer designed in a way, if the fire occurs here, we escape this way. But then we have the big problem that everybody who escapes in this way has to open the door this way, and this is not a good solution because the others are coming from behind. That's why we changed the design in the construction phase, where we said, okay, this is the door, let's say here something happens, we escape this way, this is not to be opened from inside, and you can only go this way. So you escape this way, and come here. And if you have a problem on this side, the same situation, you open the door on this side, and you cannot open then this door, you escape this way. So you go always in one direction with the opening of the doors. This made the situation a little bit better, at least what the trainings showed. This is the system of the Column Tunnel. We have a shaft here on the Styrian side, a shaft on the Carinthian side, about 60 meters deep, about 120 meters deep. The problem is similar what I heard today also from Gerard. We were not allowed to build something on this side. So it's a closed situation because there is a village. And if we would have opened a portal situation on this side, we would have a construction living on this side for the next 15 years. And the people did not allow to open the tunnel from this side with a portal. No, we do everything working from here. So if we escape, we have to escape through the shaft. This must be clear. Same situation from this side. Now we are running tunnel boring machines from this side, and these are the 16 and 17 kilometers. So the tunnel boring machines were brought down here, and they are running this side, and from here we are now working into this direction. principles. First, self-rescue, highest priority. Standby safety devices, high priority. One must accept the safety measures. In earlier times, we had a tender, and in the tender it was written, please prepare everything for safety. Of course, there is a kind of speculation, I think is very normal, and the construction companies filled in almost zero for that, because nobody knew what do they mean by safety measures. This time has gone. Now we make a very clear bill of quantities, how many things for safety do we need, and everything has to be filled in with a price. Fire prevention was mentioned, and focus on organizational fire protection also. Now, what did the tender look like? The tender said, for one lot, which is called Quorum Tunnel Lot number 2. The tender was clearly showing the health and safety plan first. It was quite, pretty new for us. And then we had an own contractual document which said technical terms contractually just for safety. And here we have a concept of rescue and fire protection written in the contract, which divides into rescue and into fire protection. And rescue then divides into self-rescue and third-party rescue. And fire protection divides into structural fire protection, technical fire protection, and organizational fire protection. And this was very clearly stated in the tender documents. First time that we have this situation here in Austria. Then next point is, following the tests which we did with the fire brigades colleagues living around this tunnel project, came to the clear conclusion that if we have a problem in the first tube and the second tube is not very close connected with the cross passages, no fireman has a chance to rescue somebody. And the tests, and we tested fire brigadesmen from Western Austria to Eastern Austria. Very funny, Eastern Austria, where I come from, we eat a lot and we like to eat. The Western like to climb on the mountains. So they are much more trained than the Eastern Austrian guys. And what came out is that they can rescue people if the distance is not more than 1.5 kilometers. If it's getting more, you have no chance even with the very well-trained fire brigadesmen, because I will show you why a little bit later. So this, to be true, was forgotten to be said in the tender documents, that this second tube has to follow in a clear distance to the first tube. So the construction company says, yes, we will follow in a certain distance, but this costs a little bit of money. And it was very clear that the cross passages have to be opened immediately after passing with the second tube. This was also not the case in earlier tunnel projects. Normally we build one tunnel, we build the second tunnel, and then we do the cross passages. But this has gone. It is very clear we need all these cross passages for rescuing if we have an accident here. And this should be clearly written into the contract documents. Now, what situations can we face? We could have the situation, the fire is here and the miners are behind. So I would say it's not the biggest problem. We install, fix a rescue chamber where they can survive for a while. The other situation is that we have the miners here, the rescue chamber here, and we have the accident down here. Then again, we bring the miners into this rescue chamber and the fire brigade comes from outside, hopefully, and solve the problem. If we have the miners behind the fire, so here's the face, the miners are at the face and the fire is behind, then we have to change this situation very quickly into situation one where the miners can pass this fire. For this reason, we say every miner has to be or has to get a fire brigade's education and some instruments to solve such problems himself. It was mentioned by Gerard that we can escape with these rescuers about 500 meters. But if the way is longer, we have no chance, because then it's empty. And if we have a tunnel, what we are speaking of, we're speaking of tunnels, kilometers of tunnels. As I said before, 16 and 17 kilometers. There's no way that somebody can survive because he has his rescuer with him. This is not possible. But if the tunnel is not more than 500 meters long, this would be a way. Self-rescue concept for short escape length into a safe area. Walking speed, in the worst case, what we learned is 10 meters per minute, so we can go about 500 minutes in about, let's say, 1 hour is possible to rescue. Now, what is when the tunnel is longer than 500 meters? The self-rescue concept with the use of one or several rescue chambers has to be the right solution. So this rescue chamber has to be placed on the right position. If this is too far away, then the colleagues from the face have no chance. If it's more than 500 meters, no chance to reach this rescue chamber. So we have to pull the rescue chamber always with us so that the distance is a maximum distance to the face of 500 meters. The oxygen self-rescuers, in our opinion, are necessary to reach these chambers, and these chambers are then serving as a safe area and have a rest for until the fire brigade comes in. The operation time varies between 4 and 8 hours of these, let's say, simple rescue chambers. This is just looking into such a rescue chamber. It's not very comfortable, but you can survive. By the TBMs, we have 2 rescue chambers per TBM for 15 persons all at all. 18 hours supply for breathing air. Communication is guaranteed. First aid, defibrillator is installed, drinking water is installed, sanitary facilities are installed inside. And about, I would say, is 2 or 3 months ago, we needed this because we had a fire at the Coram tunnel. And we were really happy to have this decision that we have these rescue chambers installed. Now, the next question is, how long does it take that the fire brigade from outside is coming? I mean, somebody has to alert the fire brigade. This takes some time. I call it T1. Then, I mean, they come, but it takes some time until they are ready to operate. This is a time number 2. Then, time is needed to reach the hazardous area. If we are speaking of 6, 7, 10, 17 kilometers in our case, in the worst case, then it will take some time until these guys are at the face. And then we have to cool down and bypass the ventilation tube. This is a T4. And the harmful atmosphere around the rescue chamber has to be replaced, and then the colleagues can be taken out of this chamber. So you see that, I mean, it's very project specific. Every project will be a little bit different, but it will take a lot of time until they can really help the people. So this is a must to install these rescue chambers. We didn't have this in earlier times, but now we learned that it is a must to have those. So this is the time we need for this chamber to survive. Is a good thing that we have a second tube. Not all projects have a second tube, by the way, and it is a must that we open these crosscuts or cross passages so that the self-rescue can be done into the second tube, and the third party can now come into via this second tube. This is a big, let's say, advantage. On the TBM, we have regeneration chamber 1 and 2. Second one is on the backup system. And then we also installed a rescue train, because you can imagine if I visit Coram Tunnel now, and we are in about 9 kilometers now, it takes me a full hour to be at the face, because the train is not running like a train, is running very, very slow. But the rescue train at least can take people out while the third-party rescue team is coming in. In case that we have no second tube, and there are many projects which have no second tube, then we should make, let's say, at least an area where we can place a rescue chamber in certain distances. We can make such a crosscut even if there is no second tube foreseen. It's a safe zone. They are available for rescuing for 48 hours, and here we can wait for the third party until they rescue us. The rescue chambers, they are then already a little bit bigger if you would like to survive for 48 hours in, and more space per person, because you have to be able to sleep inside. There are emergency beds in, there's sanitary facilities in, and there is a sluice technology. You see a door inside this chamber to be able that pollutant exposures are not coming into this area where the people would like to survive in. The rescue train I mentioned already. It is a part of the railway system which is installed for mucking, for bringing in the support materials, the tubing elements, precast segmental linings. It is a part of the railway system. It is a driving rescue chamber. You see here the inside of this rescue train, 25 seats in with 5 beds, 8 hours for air supply, independent communication possible, and additional equipment for first aiders and third-party rescuers are installed. It's a very, I would say, a very comfortable train nowadays. And I'm back to the tender document. We said self-rescue and third-party rescue has to be done, and this, as mentioned also by Gerard, has to be trained in regular time distances. We saw almost the same figure. The construction company organizes the internal trainings and instructions, first aid, first and advanced fire fixing, extinguishing aid, regulation for hot works, fire protection plans according to construction phases, and the training of underground guides who know where to go. A construction site leaves, so yesterday was completely different from tomorrow maybe. So these are the things which we have to train. External third-party rescuers have to be trained. We have a portal fire brigade, site inspections and training. So the fire brigades from external have to be able to visit the construction site in regular time distances. So they see what is going on. The determination of expectations and operation limits has to be explained, and alert and the emergency operation planning has to be done. By the way, the Semmering base tunnel, for example, I mentioned before, here we have a shaft 60 meters deep, and then 17 and 16 kilometer long tunnel drives. The external fire brigades accept it. Yes, we will do trainings and. We have at the moment the big problem. The Semmering base tunnel has 2 shafts 450 meter deep, 4 drives in different directions, and here the external fire brigades refused. They say we will not go into this tunnel system. It's too dangerous for us as a fire bridesman. So we have to solve this problem anyhow. It's not solved for the moment. But when the professional fire brigade already says too dangerous for us, then we know at least we have a really big problem to solve. Why is this not so easy to be a fire bridesman under our conditions? Oops, I jump through not all the details what a fireman has with him. But at the end, please have a look at the weight what each fire bridesman has to carry when he goes underground. He has to carry about 30 kilograms. And these 30 kilograms is a big weight to carry under these circumstances where he normally never is. Our problem is that normally we have no fire. So it's a very rare let's say, situation that we have a fire underground. Normally they are trained to help us on the motorways, but not in a tunnel. So it's a very unusual situation also for the fire brigades men with this weight to carry. Another point is underground we have the problem of getting harmful atmospheres from the rock mass on the one hand side, methane, carbon dioxide, from the machinery on the other side, carbon monoxide, carbon dioxide, nitrogenous oxides, also by the explosives, these nitrogenous gases. And then, of course, from the fire, carbon monoxide, lack of oxygen, nitrogen oxides, and then these hydrocyanic acids, very, very poison gases. Yeah, I come to another topic, Brenner Base Tunnel. A situation which also for us Austrians and Italians is pretty new. This is a quite long tunnel from here to here, as I said, 55 kilometers, but we will connect this tunnel with an existing tunnel which is already 11 kilometers long. So if we add these bypass tunnels where the trains come from Germany, in detail from Munich, come from Munich and run to, let's say, Milano or run to Verona, then they go into this tunnel, in this grey one, which is already existing, and then go into these tunnel tubes, and then go into this. And then we speak of a tunnel of 65 kilometers length, which is quite complicated. I just wanted to say where's the route going through. Europe is building a connection from Berlin to Naples, which is all in all 2,600 kilometers with a huge amount of tunnels. But one of the longest is this Brenner Base Tunnel. The very specific situation turns out because there is a border in between. Here's Austria and here's Italy. We have completely different mentalities. Yeah? The mentality of the Italian is not comparable with the Austrian, even if we are in Europe. They have completely different laws. Not comparable. We can never accept their guidelines for technical specifications in Austria and vice versa, even if the trains are running here and running there, but these are in completely different views on the safety point of view. So this is another point, and the language, we could not fix the English language for that, because you might know, Italian never speaks English, because Italians speak Italian. And if the Austrian would like to communicate with Italian, we have to learn Italian. It's a very strange situation. So all the documents are written then in German and in Italian, all documents. And the problem is that, of course, by the translation, we have some problems because the Austrian wording to be translated into Italian and the Italian translated into the German is not so easy. And there are a lot of misunderstandings due to that fact. You know, this is a complicated thing, and all the meetings are done by ladies like sitting in the room behind. And I'm not sure if, please don't take it word by word, but I'm not sure if these understanding all the technical discussions so in detail what we mean. You understand? It comes out on the right way, but there are some small nuances in between which are not translated, and this gives a lot of problems, but I hope we will solve that. The challenge is, so to say, our BPT, which is Brenner Base Tunnel, is a transnational project with different national laws and different standards concerning health and safety. And BPT is built in the Alps with a high alpine construction sites. The construction site starts at 1,300 meters, has an overburden of about 1,800 meters. BPT is a major project with 7 simultaneous construction sites in progress. Difficulties due to the transnational project are there. Differing national standards, regulations, different responsibilities and competencies on the construction site, different tender usances. We in Austria live a system where the client is doing the design with his consultants and then hand over a very detailed tender to the construction company. Italy normally has a general, let's say, contract where the design is then done by the construction company, which we call design build. So very different tendering procedures. The project-related bilingualism, what I said before, is not so easy. And we have a control station for emergency cores, but even there we had a big fight who is responsible for the safety in the whole tunnel at the end. I don't want to go into the details, but just to give you an idea, Austria has a completely different electricity power supply than Italy. So we have a different frequency in the electricity. And. So where do we change this electricity? At which point? Is it the border or is it anywhere else? Who is responsible for the safety? I mean, if I'm a passenger in a train, I'm not interested who is then rescuing me. I want to be rescued. But who knows where the train is exactly at the position where the accident occurs? And so we have a lot of things to discuss. The construction already started, but is not really solved. What was suggested is an implementation of a superior, generally applicable standards, and these are European standards. Following the European standards, Austria would have to change its electric supply, which we have the same than Switzerland and Germany. So I'm sure it will take some time until we change the electric power system. Development of generally applicable health and safety plans. Elaboration of an agreement on health and safety with trade unions from Austria and Italy. Coordination of emergency services in Austria and Italy. Has to be done in the standardization of alert and operation plans, emergency plans, and so on. So this supranational control station could help us. We will install it right on the border between Italy and Austria, where Italians and Austrians will sit, and this is a first step to solve this problem. Just to give you an idea that with having a transnational project, we focus really new problems. Just to give you the background information, Italy is quite big. In the south, we have the Sicilians, and in the north, we have the southern Tyrol, as we called it. We thought the Brenner base tunnel will have employees from southern Tyrol because they have the, let's say, similar mentality than the Austrians, but they didn't. The Sicilians are sitting there, in there. Yeah? This would be if we would bring Viennese people to Tyrol, because the language is a little bit different. It's Austrian, it's German, of course, but you know, the speaking is a little bit different of the southern and the eastern part of Austria. However, another topic, traffic in the tunnels. What you see here is we did, let's say, a deposit, not for the end, of course, and the miners are going there, and the lorries are going there. So there was a definition by the workings inspector that we have to make a kind of pedestrian. So miners, if you walk out from the tunnel, please go there. This is the wish, and this is the reality. Here is the pedestrian, and the miners are walking here. This was not foreseen. So, as you see, the training is missing a little bit, because if this is the reality, then we can forget to have this pedestrian here. And the working inspectors, of course, argued that this cannot be the case. Another point is the Brenner base tunnel has, I think Gerard already mentioned, also quite big access tunnels. This is an access tunnel of about 120 square meters, and the working inspector said, okay, you have one tube, how will you rescue if you have an accident there? Because the access tunnel is about 3.4 kilometers long and has an inclination of about 10%, so it's quite hard to run out of it. And he said, okay, please then build a tunnel in the tunnel, so if you have a problem there, so that the people can escape through this extra tunnel in the access tunnel. It's the first time that we got this drawing from the working inspector, but why not? It's a good idea. With known ventilation in this area of these 3.4 kilometers during construction, of course. Yeah, just to say something on the measures on the equipment. I don't know how you do it here. We had a lot of loud alarmings when lorries went back and forward and blinking and you know, a sound, always a sound. And even this didn't help. A lot of lightings, alarming systems, so we stopped that. It is then now clear, white lights in direction of motion, red tail lights, orange flashing light only during the reversing, only in direction of restricted visibility, and no acoustic alarm anymore. Because it was so loud, because every lorry, every machinery had an acoustic warning. And then at the end you hear nothing. So this was completely stopped, no acoustic alarm anymore. The parked equipment should have a parking light, is clear, and a flashing light, just if there is it's standing in a position where it shouldn't. Information and instrumentation to all the staff who is working there should be done. For every person who is entering the tunnel, an instruction should be done. Groups who visit the tunnel are restricted to be smaller than 15 persons nowadays, so it's also hard for us as a students group, sometimes bigger. What should be the contents of the instruction at least? At least right or left-hand traffic. Priority rules for machines and pedestrians. Who is first? Then priority rules for crossroads at entries and exits. A speed control. You will say, yeah, what do I need a speed control for? But our colleagues who are sitting on the big machines, 400 kilowatt and so, they are 18 years old, they are really enthusiastic by driving these machines, and they go up to 50 kilometers per hour in the tunnel. So you have really to be careful not to stand in the position where the machine is coming. So speed control is a must. Entry prohibitions, parking regulations, signal regulations should be done at least. Another point, working at high work sites. The working inspector came and said it's forbidden to work in the shovel, but it was done for years. And then, yeah, you know, the miners said, okay, they say it's forbidden, but we do it, however. And at the end, we found a solution. They are still allowed to work in, but get this. And the working inspector said, okay, is better than it was before. Main hazards, of course, are falling down of stuff. Now, we would like to control it by this solution. Rock fall is a topic, technical failures of the devices, and get run into and over the vehicles. So this has to be trained in internal trainings with the staff. I don't want to go into the details to work in high alpine regions. You have it in your books, but I deleted it in my presentation, not to be boring, because I had almost the same slides than Gerard. But what has to be done is to look in the bird's view and mark all the dangerous areas which could cause, let's say, avalanches and all these things. So such a plan is a must in our opinion, to be clear where are the dangerous zones and what are the measures what we can do in these dangerous zones. I think what was mentioned by Gerard, there is a ITER working group, Health and Safety. They publish these guidelines. You can download them for free from the ITER worksite homepage. There are, I think, all in all, almost 5 of them, compressed air works, and then different kinds of that. Then we have an own recommendation written, which is called Recommendation for Planning and Implementation of an Occupational Health and Safety Concept on Underground Work Sites, was written by DACH. DACH is standing for Germany, Austria, Switzerland. Is available in English, is now under construction, I would say again, because some things were not best written in, but is available also. And I come to my conclusions. Health and safety says every tunnel project is different, so we cannot make a health and safety concept and that's it for the rest of the life. The creativity of concepts depends on good brains and the willingness to cooperate. What I mentioned before by the hammering is not a really good cooperation when the client says it's your duty and I'm out. Yeah? Because the law says it is the duty of the client, even if they write it into the contract. Standards have to be implemented. Communication in order to develop good solutions is very important. The coordination of planning has to be used as a chance in terms of equal opportunities. Be very clear in your design drawings, in your tender documents, so that the construction company can calculate on that. Detection and monitoring of pollutants in the atmosphere is a technical default topic. And the challenge is the development of a correct protection system in combination with a thoughtful concept of self-rescue and third party. Third party alone, as I showed, will not work because it lasts too long until the rescuers can really help you. The decision between a functional and a technical tender is through the client, of course. As I said, we are going very much in detail on the client side, but not every nation does it. The job for the client does not end with the publication of the tender. It is his responsibility to be the first man or woman in the safety questions. Clear determination of responsibilities is a must. Definition of communication and information chains is a must. Common determination of necessary details. Self-rescue before third-party rescue again, and acceptance of necessary time and material expenditures for health and safety. Also, Gerard mentioned, we have to give the miners the time to train in, of course, the work is a normal working hour, not in their free time. Must be clear. And safety is not static. It's not a static state, but a dynamic behavior, because our construction sites are moving, are developing, and changing every day. At the end, I can say, this is the question. The essential question in health and safety is how to get the right balance. Is this the right, or is he on the right side? So we are maybe somewhere in between with the right solution. And that's it. Thanks for your attention. It was a hard and long day, but I would be happy to get your questions still. Thanks for your attention.